Hey guys, welcome to another video. Today's learning objective is to use the vocabulary of prime numbers, factors, multiples, common factors, common multiples, highest common factor, lowest common multiple, prime factorization, including product notation, and the unique factorization theorem. Bit of a mouthful, but we'll get into it. As usual, feel free to skip to any part of the video, thanks to the timestamps here. Okay, let's get into it. First thing I think there's a lot of terms here to define. So the first thing I'll start off with defining is kind of factors. You might have heard this before. Just to check if you do know this, what are the factors of A? Give the video a pause and have a think if you can remember what they are. Actually, let me give the answers and then you can kind of come to maybe you can derive the definition that way. That's a 2 and a 4. So if you can kind of tell me why these are the factors of A, then you should probably know what factors are. But if not, don't worry, well, I'll explain it right now. The factors of a number are basically kind of what the number can be divided by. So if I can do, for example, you can do 8 divided by 2. And since you get a whole number here, we know 2 is a factor of 8. And the same way, we can go 8 divided by 4, which equals 2. And so we know 4 is a factor of 8. And so basically, if you can divide 8 by a certain number and you can get another whole number, those two numbers are then the factor. So in this case, since you can divide 8 by 2 and get a whole number, 4 is a factor and 2 is a factor. So that's what the definition of factors are. Now let's talk about prime numbers. Prime numbers are a bit more kind of, here it is, prime numbers. Prime numbers are quite an interesting concept and they come up a lot in math, especially kind of later down the line. So they're quite important to know. So prime numbers are basically numbers which only have 2 factors, themselves and 1. So let me give you an example of a few prime numbers and then you can perhaps see why they're prime numbers. So say 1, 2, oh actually not 1, sorry. 2, 3, 5, 7, 11, 13, and so many more. So say for example 5. The only number that you can divide 5 by and get a whole number is 1 or 5. And that's why 5 is a prime number. There's only 2 factors, 1 and 5. Which means that by our definition it's a prime number. But take for example, say 27. Well, we can divide 27 by say 3 and get 9. So we know 27 is not a prime number because it's got factors besides 27 and 1. Now that we know what prime factors are, let's go back to our kind of list of things that we need to cover. Well, multiples. Multiples are almost like the opposite of factors. So say the multiples of 8, for example, a multiple of 8 is, for example, 16. Because you can go 8 times by a certain number to get 16. And for example, 8 times by 4, which is what, 8 times 4, anyone? Any takers? 32? Is 32, for example. So 32 is a multiple of 8, because 8 times by a certain number gives you this. Now, common factors. Common factors are, so say you've got 8, and then you've got the factors of 8, which I've listed as 8, 1, 2, and 4, right? And then you've got the factors of, say, 10, which are, say, 10, 5, 1, 2. Well, what are the common factors? What of 8 and 10? Which numbers are common here? We've got 1 and 2, which exist in both. So the common factors of 8 and 10 is 1 and 2. Likewise, common multiples, for example, of 8 and 10 is, say, we can go 8 times by 20 to get 160, but we can also do 10 times by 16 to get 160. So since 160 is a multiple of 10 and 160 is a multiple of 8, 160 is a common multiple. Now let's talk about the unique factorization theorem. It's this thing here. What this says is that for factors of a certain number, right? So it says that every number there is, right, can be factorized into prime factors. So say there's a number like, I don't know, 50. it says that you can kind of break its factors down into a multiple of prime numbers. So you can, and then I'll talk about so knowing this, you don't really need to know the proof of this. You just need to know that it's kind of true. Let me show you how it's kind of you would break it down. So you have 50, for example, and let's factorize this into its prime factors. Well, if I want to break it down into its prime factors, I have to think. Let me think of two easy factors straight away. I know it ends in a 0, so it must be divisible by 10. So 50 divided by 10 is 5. So we know 5 and 10 are factors. We know 5 is a prime number, so we can't really factorize that further unless we write 1 and 5. There's no point in writing that. And then we've got 10. So 10 goes into 5 and 2. And there you go. 50 is a product of its prime numbers. And that's what prime factorization is. You take a big number like this, and you break it down into its factors, which are all prime numbers. And this can always work. So there's never a case where this doesn't work because of the unique factorization theorem. So I think, and now we have to cover what highest common factors are and lowest common multiples are. Well, so we talked about what common factors are, going back to this example of 8 and 10. Highest common factors is saying which number here, which common factor is the highest, basically. In this case, that's just 2. That's all it is. And the lowest common multiple is saying that can we think of a multiple of 10 and 8, which is the same, and it's the lowest possible. So in this case, it could be, for example, say 80. 8 times 10, or yeah, 8 I'll have to cut that out actually, sorry. So for example here, that could be 40. 10 times 4 is 40, and 8 times 5 is 40. So that's an example of lowest common multiple. Let's move on to the questions. So this is asking us to factorize into prime numbers, 90 first and then 34. So let's do A, 90. Okay, how are we going to approach this? Let's look at 90 and see, obviously, kind of which two numbers can it be divided into. I know I can divide 90 by 10 pretty easily because it ends in a 0, right? So I know 90 divided by 10 is 9, so it'll be 9 and 10 are 2 factors. Now, let's break down 9 further. We know 9 is 3 squared, right? So we can go 3 and 3. And we know 10 is 5 times 2. So the prime factors of 90 is 3 times 3 times 5 times 2. But you can also write 3 times 3 as 3 squared, right? So you can have this. And this is called product notation. It's mentioned in the learning objective, so it's quite important to know that. Now let's try B. Why don't you give the video a pause and see if you can tackle B, the prime factors of B. Make sure you kind of use this factor tree here, it's quite helpful. And just think of which numbers it can be divided by pretty easily. Did you give that a pause? Did you give it a go? Did it come up? How did it go? Yeah, alright, okay. Well, if not, we'll give it a go now. Okay, 34. I see 34, I know it's an even number, right? Because 4 is an even number. So I know it can be divided by 2 pretty easily. So 34 divided by 2, 17, to math's not great. 2, 17. Oh, and 17 is actually a prime number, isn't it? Because I'm thinking through my kind of divisibility rules, thinking, is there anything I can divide 17 by? I know I can't divide it by 2. I know I can't divide it by 3 because 7 plus 1 is 8, which isn't divisible by 3, because that's our divisibility rule for 17. So at this point, it's really helpful if you do know your divisibility rules. And you just work through your divisibility rules, and you can kind of tell 17 isn't divisible by anything else, so it's a prime number. And so if we see a big number like this, don't always kind of get worried that you need to divide it further, because it could be a prime number. Just make sure you know your divisibility rules and see if it can be kind of divided into anything else. So 34 is equal to 17 times 2. Okay, let's move on to another question. Find the highest common factor and lowest common multiple of 60 and 90. Okay, so there's actually a method to find these that is not too difficult. So first thing we do is, for each of them, for 60 and 90, we do the prime factorizations for each of them. So we have 60, and we do the prime factorization. Okay, we've just done a few of these, so give this one a go if you didn't give the last one a go. 60, 6 and 10, right? And then 3 and 2, and then 5 and 2. So we know 60 is equal to 3 times 2 squared times 5. Okay, let's do the same thing with 90. Okay, again, because it's divisible by 10, right? 10 and 9, and 5 and 2, and then 3 and 3. So 90 is equal to 3 squared times by 2 times by 5. And now, okay, you can write 60. I'm going to write this out again, just so it's a bit easier to see. Okay, so if you want to find the highest common factor, we know, say, for example, 3 is a common factor, and 5 is a common factor. But here, if 3 and 5 are a common factor, we know 15 is also a common factor, right? And also, there's another 2 here, for example, so we know even 30 is a common factor. So what I do is I say, okay, these guys both have 3, so circle that. They both have a 2, circle that. They both have a 5. So that means 60 can be written as 3 times 2 times 5, which is 30 times by 2. And 90 can be written as 30 times by 3. So that means 30 is the highest common factor, because all the factors higher than 30 for 60 is just 60 itself, and same thing with 90. So 30 is the highest common factor. So I can write HCF is equal to 30. Okay, so there's actually a bit of a trick here. What you do is you take this 30, you times 30 by the 2 here, and then you also times it by the 3 here. And then you can actually ignore this 30, because since it's the HCF, you've also already accounted for it up here. And so you just do 30 times 2 by 3. So LCM is equal to 30 times by 6, which is 180. If you kind of want to see a proof for that, I'll include something in the description which gives it a bit more detail. But you should, you can always use a technique and it should work out. But if you do want to check the proof out, and there'll be a description there, so do make sure you check it out. Thanks very much for joining me in this video, guys. It was a pretty big video, pretty comprehensive, so it's really important that you do practice all the different concepts that were covered, especially the prime factorization stuff. You just need to if you do this over and over and over again, you'll get really good at it. You can do it really quickly, and it's really important, especially if you know your mental math. The more you know your mental math, the easier it will be to find these factors and then go back into prime factorization. And once you can do that kind of stuff, everything else comes along a lot more easily. So just make sure you focus a bit on mental math, and then do a lot of practice on these questions, because there's a lot covered in this video. Thanks very much for joining me this time around, guys. See you guys in the next.